Alright, let's go over the review for the test. Alright, number one here, what is the degree of the lead coefficient of this graph? Well, the degree is negative since it's going down. And the lead coefficient, well, since you can see 1, 2, 3, 4 zeros, and you can see that it's an even function because both sides, both end behaviors are down, you would probably assume it's a fourth degree, and it's a negative lead coefficient again because it's all down. Now this next question is kind of weird. This is f right here, this is g, this is h. It wants to know, could this graph be the product of these two functions? Well, if we were to multiply these two functions with FOIL, what you would notice is when you FOIL it out, you'd be multiplying the negative 2x to the third times negative 5x squared. When you multiply those, you'd have a 10x to the fifth, which is a positive lead coefficient and a fifth degree. Since this is a negative lead coefficient and a fourth degree, there is no way when you multiply these it would become your f of x, this graph. So there is not a possibility because if the positive lead coefficient in the fifth degree does not match what the f of x is. Alright, the next question. So let's take a look. Let's move this up. Here we go. If we look at this next one, if f of x equals this, then g of x is f of x plus 2. So what this is saying is g of x is take f and plug x plus 2 in. So see here for each x, look right here. See what I plugged in for each x? The x there, the x there. Do you see how I plugged in x plus 2? When I plugged in x plus 2 into both, here I got a cube, so I write it 3 times, and I first FOILed, and then I used the box, and then when I bring this box together I get this thing in the parentheses. Here I distributed the negatives, I get this, and then as you can tell I combine like terms, and this is your answer. Number 3, describe the transformation of f of x equals x cubed. So what would an x cubed graph look like if you did all this to it? So first of all, the a value tells us we are going to flip it and give it a vertical shrink. Remember, anything less than 1 is a vertical shrink, any negatives are flips, and the factor is by 1/4. The h is your horizontal shift, and it's always opposite, so that's a negative 5, so we're going to go in the opposite direction 5. So we're horizontally shifting right 5, because right is positive, and that's opposite of a negative 5. And then the 2 here tells us our vertical shift, and since it's positive 2 doesn't do opposites, that means it's vertically shifting 2 units up. Alright, let's talk about number 4 right here. How many third degree polynomials have zeros of negative 4 and 6? Now see negative 4 and 6 here as your zeros? Can I have infinitely number of functions through that? Right there I have 3, f, h, and there's another one, g, you can't see. But I could have infinite number of third degree polynomials because your a value tells you how high or low these humps are. Okay, so no matter what your a, there's infinite number of a values, so the answer is infinity. There's infinite number of a values that will always go through negative 4 and 6. So a third degree. Now if I gave you an exact a value and it's a third degree, there's only one. If I knew a third degree and I gave you your a value, there would only be one possibility. But since I did not give a specific a value, all I have is a third degree in the zeros, I could have infinite number of them. Now this problem's a little tricky. I want to find the volume of a box. The width is 3 inches longer than the height. The length is 4 inches shorter than the height. And the volume is 108 cubic inches. So the question is, what's the height? We have these 3 choices. Now without these choices, this problem would be really tough. Over here is the algebraic way of doing it, dealing with this chapter. Over here is the simple, just kind of guess and check. So if we think about it, h is our height, and we know that the width is going to be 3 inches longer. So wouldn't that be height plus 3? And the length is 4 inches shorter, so that would be height minus 4. And when you multiply all 3, it should be 108. Then, if I FOIL, I get all this. Then I minus the 108 over, and now I have this trinomial. Now I want to find my zeros. So to find zeros, I can use remainder theorem or synthetic division. As you can tell over here, I use synthetic division instead of remainder theorem. Now, 4. Well, you should think real quick, 4 doesn't make sense because when you go 4 minus 4, you get 0. You can't have a 0 side, so that one I could cross out. Now I plugged in 5 inches. When I plug in 5 inches to this right here, 1, -1, -12, -108, I get a remainder of -68, so it doesn't go in evenly. When I try 6, it goes in evenly, so that means that 6 is a 0 for this, which is, that's what I want. I want zeros. So I know that the height is 6 inches. That's a lot of work. Probably easier way would just be to logically go 1 by 1. Okay, 4 you said doesn't work. 5, well, if you have 5 as the height, the other one would be 3 more than that, which is 8. And the other one would be 4 less than that, which is 1. That does not equal 108. And then we do 6, same thing. You add 3, subtract 4, multiply, you get 108. That would probably be the easiest way, so I'd recommend that most of the time. But I want you to think of this way, because this is with what we're dealing with. That's the type of problem we are working with. But, all right, this next one is right here. Let's do this one. So, for this particular problem, write a standard form polynomial with a -2 lead coefficient and a 0 of 1, 2, and -3. So there's your lead coefficient of -2, and there's your 3 zeros. Remember, zeros are the opposites when you write them as factors. Okay, factors, again, are the opposite of the zeros. That's another way of saying it. So I distribute this, I FOIL this, and then I box the two answers, and that is my standard form polynomial, second degree, and they would have these 3 zeros. Alrighty, and the last one here, which would be the graph of f of x of this function. Well, first of all, if you're choosing multiple choice, this is x cubed, so you know right away it's not going to be x squared, parabolas. I know it's a positive x cubed, so I know it's not going to be a negative downhill one, so it's one of these two. So to choose between these two, we have to either factor this and see what the zeros are, or take 1 0 at a time and find out if it's true. Meaning I'm going to check 0. If I put 0 into the function using remainder theorem, I get a remainder of 0, which means that 0 is an x-intercept, aka 0. So which of these has an x-intercept of 0? Or that one. So my answer is C. Now I could also check like 1. See how they both have a x-intercept at 1? So we could verify that. Watch. Instead of remainder theorem, I'm going to use synthetic division. Alright, when I do synthetic division using this 1, 2, -3, and 0, this 1, 2, -3, and 0, when I do synthetic division, it has no remainder. So what that means is 0 and 1 are both zeros, or x-intercepts. And you see how this one has a 0 and 1 x-intercept, which is kind of verifying once again this is the answer. Yes, this one has a x-intercept of 1, but it doesn't have one of 0. So we know this is probably should be your answer out of the choices. Now, for this particular problem, what is the remainder of this division problem? Well, instead of doing long division, let's do synthetic. You could also do remainder theorem. When I plug in -5, I get 46. That's my remainder. Again, if I plugged in -5 to this, I should also get an output of 46. That's another option, or long division. Number 9 here, what is the degree of this? Well, the degree, you have to remember, is you look at the factors. The number of factors is the number of degrees. So this x is twice, so that's xx, that's 2 x's. There's 2x minus 3's, and x plus 4. So that'd be 1, 2, 1, 2, 3, 4, 5, fifth degree. So again, the number of factors is the number of the degree. Number 10. If x plus 7 is a factor of g of x, then what do we know about g of x? Well, here's some of the things we know. We know that -7 is a 0, which is also root, which is also x-intercept, just different names of the same thing. Because remember, if x plus 7 is a factor, the opposite is a 0. Okay, so we know that. We also know if this is a factor of g of x, that when you divide, you should have no remainder. And we also know that if you plug in the 0, you should have an output of 0. These two would deal with remainder theorem idea. Okay, and this is just dealing with the basic idea of a 0. Alrighty, and this last problem right here, last couple problems here, let's see what we got. Okay, here we go. Last couple problems. So, for this one, write the function for this graph. So we first should know it's an odd degree. I look at the zeros. The zeros are -2, 0, and +3. So if we look here, 0, that's one of them. -2, the opposite of 2 is -2. And the opposite of 3 is -3. Now why do both of these have squareds? It's because you bounce off at the -2 and you bounce off at the +3. So those are squareds. See how x doesn't have a squared because you went through. So anytime you go through, it's 1. Anytime you bounce off, it's a cube. Anytime it does a twist, it's a cube. Why is it negative? Because this 5th degree is going down. And hopefully you can tell this is also a 5th degree, because 1, 2, 3, 4, 5 factors. This last one here, I want to take this to the 3rd power, so that means write it 3 times, which I FOIL. Then I multiply this, I'm using the box here, and there's my answer. When you take this to the 3rd power, you should understand it should be a cube. That should kind of be something you should be catching on to as well as you do more and more of these problems. For this particular problem, I want to take this and divide by this. Now, you won't probably want to use synthetic because you'd have to put 2/3 as the value. Because what would be the 0 is 2/3. And also, this is not in standard form. So first step is put this in standard form. So when you rewrite this, you get this. And then that's what you're dividing by. And then, as you do it, what times 3x gives you 3x cubed, so that's x squared. You multiply by both pieces, and I'm subtracting down. Bring down this. So what times 3x gives you 3x squared, x, multiply by both pieces, subtract down. That gives you negative 6x, bring down the 4. What times 3x gives you negative 6x, negative 2, okay, multiply by both, subtract down, I have no remainder. So that is my answer. Now something you also want to realize is 2/3 now is a 0 because it came out with no remainder, and if I factored that, you would get some more remainders. Some more factors of this, or factors end up being also zeros if you were to be graphing this. But that is my result when you divide the two. The last problem here, if I move this up here, alright, what do we got? Let's see here. We have area is length times width. I say this is my area, this is my width, I want my length. So if you think about that, I have my area, which is this. I want my length, and I know my width. Well, to get length, don't you divide over and basically take this area divided by your width? Wouldn't that give you your length? And when you divide, well, you could do long division. You could also do synthetic. And you get no remainder. All right? So this right here simply is your result, or your length, when you divide the area by the width. You could also use other, like long division, but I use synthetic on this particular problem because I thought maybe it would be easier, I guess.